from Hannah. So Hannah did our lovely one of the energy introductions, and now we're going to hear some about her actual research of beyond technology, human behavior in an energy systems model. So thank you, Hannah.
Thank you. Wait for the start. Yeah, so indeed, you heard already from me in the just broad introduction on like energy system models. And I thought it would be nice also to show you a bit more about what is my research actually, so to go a bit more into how can behavior in an energy system model look like, which I feel like also after the discussions of the last days is probably like, yeah, a bit of a different perspective. So maybe that helps also to think about it in a way. So just a brief recap. Let's see. Just a brief recap. So we have these big energy system models, and we want to show like pathways into the future of a renewable energy system. We usually have a lot of technological detail. We can see if we simulate over time or we optimize over time, what will be the costs of that system, what will be the adoption or the diffusion of different technologies. So that's basically, and these models differ in scope. We have national models, global models, all different types. So yeah, there's a lot of variety, and also a lot of variety in the data that is used and in the assumptions that are made. So I want to just explain just very briefly about our energy system model that we're using that currently has an exploratory behavior framework. So that means it's not really based on any data or theory. And we try to supplement that with a data-driven behavior framework, and then some reflections and challenges of that process. So yeah, our energy system model is a simulation model of the Dutch energy system. It is similar to other models in that it has these components inside. We can simulate from now to 2050 and 5-year time steps. We can see what happens to the energy system system over this time, like how many more wind parks do we have? What is the amount of solar energy we can produce if we make these assumptions? And as I already said, we simulate. So we don't optimize towards a certain state, but we simulate and we see what happens with the energy system if we put this data in and if we put these assumptions in. So then an exploratory behavior framework. Currently, this was done by an energy system modeler who was like, oh, it would be nice to just have some behavior in this model. So he came up with a framework which was more based on some understanding that he had just to explore, just to see what will happen. So how does it look like now? We have actor types, so farmers, companies, and households. These are the 3 actors in the model, and they can have different attitudes. Maybe that does look a little bit familiar to some of you. That's based on Roger's theory of innovation diffusion, though a little bit modified. So the original theory, because the person who made the model, it was not his goal to have an absolutely accurate behavioral framework. So he was like, okay, I'm just going to take what I find interesting. So we have some of the households, for example, they are more innovative. They will adopt a technology earlier. Some are more like late, on the very late end. They're maybe more critical. So that, I guess, relates also a bit to people's motivation and openness to innovation. And on the other side, you have technologies. So for households, for example, they can adopt heat pumps, and these technologies have different characteristics that you can classify them with. So environmental performance is just the CO2 emissions that you can save. So how environmental friendly is that technology? Economic performance is the cost. So that's easy, or rather easy. Then this person who made the framework added 2 additional elements. That's the social perception and the perceived complexity. So how hard is it to install that technology and how much information is there? And the social perception is a bit of like the social norm. So like how is it perceived by society as a positive technology? Maybe it's more approved if you install a heat pump rather than if you take a gas boiler, potentially, depending also on your area and on your social circle. And you can bring that together, and then you have different motivation factors that are different for these actors. So, for example, if you're very innovative, you might not care so much about the costs, but the social perception might be very important because you want to be seen as someone who's like a front runner in a technology. So this is how that came together, and then you just get a rating per technology, and then the model chooses the technology per actor profile, which is most highly rated, and that's how you arrive at a technology decision. So that's obviously useful just to have some sort of like framework that describes in a very simple way, like how do people make decisions, but as I said, it's not really based on data or really, I mean, some sort of like, in a way it's based on a theory, but also that theory is not properly, like not fully implemented. So we thought, okay, how can we back that up more with, so we focused on the households, and we thought, okay, for the households, how can we make that a bit more realistic to include also some constraints, like not everyone has enough money, like maybe you're very innovative, but you don't have enough money to get a heat pump. So there's all these sorts of things. So we thought, okay, we need to change this part to make it more realistic. So we tried to change that into a data-driven behavior framework. So we try to follow these steps, like we have the data, then we go to prepare the model, and then we put that data into the model. So I'm now basically describing the data collection and analysis step. So we chose 4 technologies which are the most commonly represented in these kinds of models, which are subject to household decisions. So that's solar panels, heat pumps, electric vehicles, and home energy improvements or home insulation. So then for solar panels, it was quite easy because let's say the non-behaviors, you don't have solar panels, and then you get solar panels. If you go to heat pump, already starts to be a little more complex, because then you can exchange your gas heating with a full heat pump, with a hybrid heat pump. You can go from hybrid heat pump to full electric. And that's the same also for the electric vehicle. So these are the different options. And then in the Netherlands, we have different energy labels. I believe that's maybe a little bit similar to the UK. So label G is your worst energy label. So that's the worst insulated house. And you can go to A+, which is like the best, most modern standards. So we try to group them, but also you have a lot of different things that a household can do. And if you think of an energy system model, the model really wants to know, okay, do you exchange your gas heating with a full electric heat pump or with a hybrid heat pump? So we need to know which households do which, because otherwise it's not detailed enough for the model. Like the model will ask for all of these different things. So we tried to analyze that. We did simple binomial and multinomial logistic regression analyses with, like, we have a very rich data set, so that's very nice, basically representing almost every household of the Netherlands. And we were able to add things in like income, household size, dwelling type, also descriptive social norm, which is like the proportion of ownership in your neighborhood area. And the idea is that then we get these coefficients out, and we know actually if you are a household of low income and with a large household size, with a high proportion of solar panels in your area, you are that much more likely to go for electric car or heat pump and these things. So the idea is to get these coefficients into the energy system model. And just some reflections and challenges on that process. Then we need a lot of data, which luckily we have quite a lot of data, but it would be nice, of course, also to include maybe values or attitudes or motivations, and that's obviously way harder also to get data on. So we have that data problem, and it's not feasible in every country and every context. The detail increases very quickly. So once you start thinking about actually what is the behavior you are trying to model, we thought it's easy, we just have 4 technologies, but already there you have so much detail. Then more and more questions can come up. So how do you deal with households moving houses? Then maybe the same household goes to a different house that has a different characteristic. So that's also something. And just to find that balance between the model complexity and the clarity. So you can add in potentially a lot of detail, but then how much of the clarity do you lose and what do you want to say? So yeah, these are kind of, I don't have an answer to these things, but it's just some reflections of things that we encountered. Yeah, that's it. Thank you.